Let's now take a look at a proportion problem. In general, you'll have, again, one of the following tests. You might have a lower tail test where you think the proportion is less than the proportion in the null, or there's been a decrease in the proportion. Or you might have an upper tail probability where you think that the proportion is increased if it is more than what the null says. And you might be interested in a two-tailed test where you are analyzing if the proportion has changed or not. And P0 here, again, is the proportion in the null. The formulas are really similar to the population mean related formulas. The z-score is not x bar minus mu, but it's p bar minus p divided by sigma p. Sigma p here is the standard error of the sample means. And how do we get that bottom part? We take the square root of the proportion in the null times 1 minus that proportion divided by n. And you have those formulas in the formula sheet, but also keep in mind that p bar is the sample proportion. It comes from the sample. Here, x denotes the number of outcomes that you're interested in a sample, divided by the total size of the sample. Let's say you have a survey and 20 out of 100 people said yes to a certain question, and you're measuring the proportion of that. The sample proportion would be 20 divided by 100, which is 20% or 0.20. Sometimes p bar will be given in the question right away, and sometimes you'll have to calculate it yourself. The rejection rules are the same. There's no difference between the proportions and the means. If the p-value is less than alpha, we can reject the null. Less than or equal to alpha, we can reject the null. And the critical score approach is the same as the population means. Here's an example. Over the past year, 20% of the players at Pine Creek were women. In an effort to increase the proportion of women players, Pine Creek implemented a special promotion designed to attract women golfers. The manager now wants to determine if the proportion of women players has increased. That's a keyword, increase. And we want to see if the proportion is greater than 20% now. So what type of a test do you think we're going to have here? A random sample of 400 players were selected and 100 of the players were women. The level of significance is alpha 0.05. Again, writing the alternative is easier because we're interested in seeing if the proportion is greater than 20%. So the alternative will determine, or the sign in the alternative will determine the type of your test. This is what you're looking for, and it belongs to H1. The opposite of that, p less than or equal to 0.2, goes into the null. The level of significance is 0.05. And now we need to calculate the z-test statistic. Find sigma p bar first. Now this piece uses the proportion from the sample 0.2, the 20% that we know right now. Because before we can reject that 20%, we will have to work with that 20%. Right? That's the current assumption. 0.2 times 1 minus 0.2 divided by 400. Don't forget to take the square root of that. That'll give you the bottom part of the z-score, the denominator. And then the numerator here is p bar minus p. We know that the population proportion right now we think is 0.2. And the sample proportion is 100 out of 400, that's p bar. 100 over 400, that's 25%. So 0.25 minus 0.2 divided by 0.02 will give you a z-score of 2.5. That is a nice z-score. That seems like a z-score that's going to be good enough to reject the null. Usually anything more than 2.5, it's highly likely that you're going to reject the null. The p-value, now the z-score is 2.5, the lower tail area is 0.9938. Let's check that. 2.5, the second decimal place is a 0. So yes, the cumulative, the left tail probability is 0.9938, but this is an upper tail test, right tail test. So the p-value is going to be on the upper tail. So we need to subtract this from 1. The p-value is 0.0062, and it is less than 0.05, which means that we can reject the null. We can say that yes, the proportion has increased. It's more than 20% now. The critical values with alpha 0.05, if we have an upper tail test, the critical score is 1.645. This number is coming from the z-chart. Our z-score 2.5 is above that. It exceeds that first point of entry into the rejection area. So we are far from our critical score, which means we can reject the null. So the two approaches are giving us the same result. In the next video, I'm going to go over finding p-values for different types of tests, and you'll have that PDF as a guide, and then we'll take a look at more problems.